Hello, this video is about how to balance equations when they're a little bit tougher. So let's start with this one right here. You can see there's a lot of elements here. We can make our life easier if we look for groupings that are the same on both sides. So you want to look for any polyatomic ions. Polyatomic ions are those things that are on the back of your periodic table on the very bottom. And I can see some right here. I've got nitrate is on both sides, NO3 1-. I can also see that I've got phosphate on both sides, PO4 3-. And so these are the groupings I'm going to have. Instead of having Cu and N and O in my atom inventory, I can have Cu and NO3. It'll make life a lot easier. So let's give it a start. So I'm going to put, I got Cu, I have nitrates, I have phosphates, PO4s, and I have sodiums. And I'm going to look at how many of each that I have. For my coppers on the left, I have 1 copper on the left and 3 on the right. My nitrates, I happen to have 2 nitrates on the left and 1 nitrate on the right. So phosphates, I have 1 phosphate on the left and 2 phosphates on the right. And my sodiums, I have 3 on the left and 1 on the right. So clearly that's not a balanced equation because I have the same numbers on both sides. So I'm going to try to see what I can do. Really, from here, it doesn't matter where you start. Not at all. So I can start in any spot that I want. I'll start with the coppers. I have 3 coppers on the right and only 1 copper on the left, so I'll put a big 3 out front here. That way I've got 3 coppers on the left and 3 on the right, but then I also created more nitrates, so 3 times 2 gets me a total of 6 nitrates. Well, let's go to the nitrates then. I have 6 nitrates on the left, and I'll have to get 6 on the right, so I'll put a big 6 out front. That way I've got 6 nitrates here, and that also creates 6 sodiums. Oops, sorry, 6 sodiums. I need to get 6 sodiums on the left, so in order to do that I have to put a big 2 here. 2 times the 3 makes 6 sodiums on the left, but it also creates 2 phosphates, and now I can see I've got the same numbers on the left and the right, so I have a balanced equation. With 3, 2, 1, if you want to put a 1 there, 6, balanced equation. Another one we got to balance that gets a little bit trickier here is this compound, is this reaction. I'm going to do an atom inventory to see what I've got. I've got, oops, that doesn't make sense. Try this again. I've got C's, H's, and O's. I'll start counting how many I have of each. For C's, I've got 6 C's on the left and only 1 C on the right. H's, I have 10 H's on the left and 2 H's on the right. And for O's on the left, I've got 2 on the left, and for O's on the right, I've got 2 here, and 1 here makes 3. Now, if you happen to see something where you have C's, H's, and O's, that's the order you want to balance it. Balance C's, then H's, then O's every single time. Keep this order. So that's what I'm going to do. I start with my C's. I've got 6 C's on the left, so I need to create 6 C's on the right. So I'll put a big 6 out front, 6 CO2s. I'm doing C's, then H's. I've got 10 H's on the left. I'm going to need 10 H's on the right. In order to do that, I have to put a 5 here. 5 times 2 makes 10. Now I'm going to recount my O's because I put in numbers and things change. So 6 times the 2 makes 12 on that one. Plus 5 O's right here makes a total of 17. So now I need to make 17 O's on the left. To make 17 O's, it's going to be pretty tricky. So I can't have any whole numbers that go in there. So if I think about it, 17 divided by 2 gets me 8.5. If I could put 8.5 there, then 8.5 times 2 would get me 17. Now you might be thinking, but you can't do half of an atom. You're totally right. You can't. So you can't really have 8.5 there, but that goes in my second part of my hint. If you want halvesies, in other words, if I want to put in 8.5, then do it, because then you're going to multiply everything by 2. So now, if I follow my rule, if you want halvesies, do it. I got it in there. Now I'm going to multiply everything by 2. That means this whole equation by 2, which means now I've suddenly got 2 C6H10s. 8.5 times 2 is 17 O2s. 6 times 2 is 12. 5 times 2 is 10. And if I go with this, this is a balanced equation. We'll double check it anyway. 2 times 6 to get my C's is 12. On the other side, I have 12 C's also. This one's good. Looking at my H's, 2 times 10 makes 20. On my right side, I've got 2 times 10 makes 20. H's are good. Taking a look at my O's, 17 times 2 makes 34 O's on the left. If I look at my O's on this side, I've got 12 times 2 makes 24, plus 10 more makes 34. And it's balanced if I do 2, 17, 12, 10. That's the trickiest kind. Ooh. I hope it went well.